Lesson 96 has two parts. The first part is on estimating angle measures, and the second part will be working with the distributive property and using algebraic terms. First, let's talk about estimating using a clock face. And one reason we're doing this is because in a circle, you can break a circle up into 360 degrees. Now, what I have on there are the hour marks on that clock that I've drawn, and each one of those is 5 minutes apart, right? Now there's 60 minutes in a circle. So think about a rate here. There's 360 degrees in a circle, 360 degrees per 60 minutes, because there's 60 minutes in a circle as well, right? So we can end up getting 6 degrees per minute. I don't have the minute marks drawn on here, but I do have the hour marks, and there's 5 minutes in between hour marks. So think about that. 6 degrees per minute. We could do a unit multiplier problem times 5 minutes per 1 hour mark. Our minute units cancel, and we end up with 30 degrees per hour mark. Knowing these two things, that there are 6 degrees per minute and then 30 degrees per hour mark, that second one will allow us to answer all of those practice problems there. So why don't you see if you can answer each of those problems. Assume that all of the rays are passing through hour marks. Even though, like ray A, it looks like it's a little bit past that first hour mark there, the 1 o'clock mark, but it is supposed to be going through it. So angle AOB, just think about that one. We're going from here to here. We go 2 hours, right? There's 30 degrees per hour. So angle AOB is 60 degrees. Angle AOC, look at that one. Just count up the hour marks. 1, 2, 3, 4. So we can estimate 4 times 30 is 120. That's a 120 degree angle. Angle AOD, look at that one. We have 1, 2, 3 hour marks that we can see in between those two. So that would be a 90 degree angle. And if you look at it, that makes sense, right? You could put a little right angle box there on the corner to notice that that is a right angle indeed. Now the last one, angle DOC. Just count hour marks up. 1, 2, 3, 4, 5 of those times 30 would be 150 degrees. Almost a straight angle. Try to remember those relationships. 6 degrees in a minute. 30 degrees in an hour. There's 360 degrees in a circle. If you've ever used a compass, you know a compass has a circular shape to it, and there's 360 degrees on the compass. North is at 0, and then you go around to the right. East is at 90, south is at 180, west is 270, and then you get back up to 0 degrees, which is the same thing as 360. Now those problems that you just did, you kind of had to estimate, but you used a general rule that there were 30 degrees per hour mark or 6 degrees per minute mark to help you with your estimate. Now on these problems, on E, F, and G, I want you to really estimate. Just kind of look at that. And that's, you use angles a lot, and you'll be using them even more in the next few years in your mathematics. So it's good to just be able to look at something and say, oh, that's a 50 degree angle, or that's a 45 degree angle. Why don't you try to estimate each of these angles that I have up here, and then I'll tell you what the actual answers are. If you want to try to measure, estimate it first, and then put your protractor up on the screen, you can do that to try to get the actual result. So angle AOB, that's a 30 degree angle. Angle AOC, That's an easy one. That's 90 degrees. 90-degree angles are usually pretty easy to tell. And then angle AOD, that one is 120 degrees. Now make sure you know how to measure each of those angles and know what they are using a protractor as well. That's an important skill, is to be able to use a protractor to measure an angle. Now let's talk about the distributive property. You were first introduced to the distributive property back in lesson 41. And remember, there's a couple of ways you could do a multiplication problem like this one here. You could do the addition on the inside of the parentheses first and say 2 times 7 equals 14. Or you could use the distributive property. Remember what that is? You distribute the 2 over the 3 and the 4. The distributive property of multiplication over addition. And so you would say 2 times 3 plus 2 times 4, which equals 6 plus 8, and that is 14 again. Now, there's two ways to solve that problem, but what if you had this, A parentheses B plus C, if you had it all in terms of algebraic terms, letters, or collections of letters and numbers? You can't do the first way that we did that. You can't just add B and C together because that doesn't make any sense. You have to use the distributive property to change this. And so you would distribute A over the B and C and end up with AB plus AC. A lot of times in algebra you want to use the distributive property on a set of terms to simplify an algebraic expression. Let's do a few problems dealing with the distributive property, and what I want you to do is simplify each of these expressions. Anytime you're asked to simplify an algebraic expression, usually that means to get rid of the parentheses and add like terms where you can. Your first step will always be to get rid of the parentheses. So if you want to, pause the CD and go ahead and work these on your own, or you can follow along with me. On the first one, we need the distributive property, and we distribute that negative x over x and over negative y. So we say minus x times x, that would be a minus x squared. And then minus x times minus y, two negatives, that would give us a positive xy. And so there's our simplified form of that expression, minus x squared plus xy. Look at I. We have minus 4 times 3x plus 1. Take the minus 4 and multiply that by 3x. That would give us a minus 12x. And then take the minus 4 and multiply it by positive 1. That would give us a negative 4. So that's the simplified form of that algebraic expression. J, we have x squared plus x minus 3 times 2x plus 1. So we need to do the distributive property, or in other words, expand minus 3 times 2x plus 1. Sometimes that's what that is called. When we use the distributive property, we're expanding that relationship. Let's do that first. X squared plus x minus 3 times 2x would be a negative 6x. And then minus 3 times a positive 1 would be a minus 3. Now notice here we have like terms, a plus x and a minus 6x. So we need to add those together. We haven't simplified this completely until we do that. X squared minus 5x minus 3. That's the simplified form of that expression. Let's do one more. Again, we need to do our distributive property first before we do anything else. And we can't just add negative 3x and negative x together, because that negative x is a factor in negative x times x plus 1. So we need to do the distributive property first. That's why it's just always a good idea to get rid of your parentheses first in any of these problems so you don't get confused on what you're doing. X squared minus 3x minus x times x would be a minus x squared. And then minus x times 1 is just a minus x. Here we have two like terms. We have x squareds and we have x's. X squared and a minus x squared would just be 0. So we can just cancel the x squareds out, and then we're left with minus 3x and a minus x, or minus 1x, which would give us minus 4x. And that's our simplified form for that problem. Now that one simplified quite a bit. They don't always simplify that much. Just depends on the problem. Distributive property, you just multiply that outside term by the two terms on the inside. Okay, well that's all for lesson 96.